Hi guys, so in this video we're doing momentum. This is question 4, basically momentum problems. So you're more than welcome to pause the video and attempt the problems by yourself. Right, right, let's get into it. Now this is a different type of momentum. Right, this is question 4. This is a different type of momentum because before you read the question, the first thought that comes into everyone's mind is work energy, which is okay, due to a ramp and the blocks, and yeah. But then this is not work energy, it's momentum. Maybe it is, but momentum. Let's read the question statement. Now, a trolley of mass 1.5 kilogram is held stationary at point A at the top of a frictionless track. When the 1.5 kilogram trolley is released, it moves down the track, and then it passes point P at the bottom of the incline and collides with the stationary 2 kilogram trolley at point B. Now refer to the diagram below. Ignore air resistance and rotational effects. Okay. Oh, rotational. Alright, now 4.1. Use the principle of conservation of mechanical energy to calculate the speed of the 1.5 kilogram trolley at P. Okay, so I'm sure everyone is familiar with the formula. 4.1, mechanical energy before is equals to the mechanical energy after, right? So I'm sure everyone is familiar with this formula, right? So this is the mechanical energy at A. It's equal to the mechanical energy at P, right? All right. Now we're gonna say potential energy plus the kinetic energy is equals to potential energy plus the kinetic energy, right? Good. Now this is top bottom. I just called it initial and final, which is okay. So we know that potential energy is defined as mass times gravity times height. Kinetic energy is 1/2 mv squared, and same goes for the other side. Now, for someone who's wondering, so why should I write both of them? Here's why. Now, remember this is at the top, right? So since this is at the top, it's not moving. They said it's released, so it's not moving at A, right? It only starts moving when it's along the ramp, right? But at the top, it's not moving. So we know that it's going to be 1.5, 9.8, 2, right? The kinetic energy is 0 because it's not moving at the top. But then once it reaches the bottom, do you have a potential energy? Do you have a height? No, you don't. It's 0. So on this side, then we do have the energy here, or let's just say the kinetic energy here. We have it because it has moved, and it will still be moving by the time it reaches P, right? So this is what we are looking for, right? The V squared. So you can simplify it or not, but let me just simplify it with you guys. So 1.5 times 9.8 times 2, of which it's 29.4, then the 1/2, 1.5, it's 0.75 v squared. Now you're going to divide both sides by 0.75, and you should get 39.2. 39.2 square both sides, then your v is going to be 6.26 meters per second, right? Good. All right, we're done with the first question. Moving to the second one. When the two trolleys collide, they stick together and continue moving with a constant velocity. I'm reading the question, by the way. And since they said they move with a constant velocity, we come to 4.2, and they say the principle of conservation of linear momentum is given by the incomplete statement below. Now they want you to finish it. Since they said below, they said rewrite the complete statement and fill in the missing words or phrases. All right. So in a what? In an or in what? Right? In a what? So in a closed system or an isolated system, the total linear momentum is conserved. So those are the two words that we're missing. I'll just write this one here. Total and linear. Oh no, isolated. Isolated. Good. Right, now moving to 4.3. Now they say to us, calculate the speed of the combined trolleys immediately after the collision. Right, so they want us to find the speed of the two trolleys after they collide. So we're going to use the linear momentum of conservation. Like I always say, the examiner is romantic. If he asks you or she asks you to define something before, you're going to apply it in the next question. So sum of momentum before is equals to the sum of momentum after, of which then you're going to say A V initial plus B V initial is equals to F VF MA plus MP. Alright, then since I know that initially both of them were not together and the 2 kilogram basically was stationary, since they said, I know initially the 2, I'm just gonna multiply it by 0, and this one, the first mass, which was what, it was 1.5, so it was 1.5 times by the V initial. Now what was the V initial? The V initial of this one, it was what, 6.26. Now for someone who's wondering, we took the V initial from this point of P and B for 2 kilogram. For 1.5 we took it from this point, since they come into contact with one another at B. So the VF that we're looking for and the two masses, we're going to have 1.5 plus 2, right? And from there on, we're going to divide both sides by the answer, of which, let's simplify it. So 1.5 multiplied by 6.2526, by the way, which is going to be 9.39. The VF 1.5 plus 2, it's going to be 3.5. Then our VF, it's going to be, divide both sides by 3.5, and you should get 2.68. Some say 2.68, right? Meters per second. This is not acceleration, by the way, it's velocity. Right, now moving to the last one, which is 4.4. Calculate the distance traveled by the combined trolleys in 4 seconds after the collision. Now this one, it wouldn't take much time, because if you know, or let's just say, to answer this one, let me not say that, let me not say if you know, to answer this one, we know that the V, or velocity, is defined by the change in position, or the rate of change in position, right? Displacement, by the way. Right, now we're looking for the change in x. I'll just multiply the V by the change in t to put the change in x as the subject of the formula. Now what is the velocity at the point after the collision? What is the velocity after the collision that the two objects will be having? 2.68. What is the time? Now the time they gave us, it was what? It was 3, not 0.3, it was 3. So the change in x, it's going to be what? 8.04 meters. So this is the final answer for the distance traveled by the two combined trolleys, right? So we've reached the end of this video, and if you have any inquiries, please leave them below, or any problems, you can even email me so that I can help you as much as possible, right? So just like that, guys, I'll see you guys in the next one.